Okay, so here's cosine of 22.5. I don't really know what that angle is, but since we're in the half angle section, I'm going to double this, which is 45. So if I take the cosine of 45 over 2, I get the same thing as the cosine of 22.5. So we have half angle cosine, I'll write that over here, is plus or minus the square root of 1 plus cosine theta all over 2. Since 22.5 is in the first quadrant, I don't care where 45 is, I care where the original angle is in the first quadrant, so therefore this is going to be plus. So it's plus the square root of 1 plus the cosine of 45 all over 2. So that's the square root of 1 plus radical 2 over 2 all over 2. I'm going to multiply by a common denominator of 2 over 2. So that gives me the square root of 2 plus radical 2 all over 4, which is the same as the square root of 2 plus radical 2. The square root of 4 is 2, so I'll leave it like that. So we have sine of 195. I'm going to double I'm going to double 195, which is, I just did that on the side, is 390 divided by 2. So I've now turned a traditional angle into a half angle. Let's assume the directions here said you had to use a half angle. This might be the sum or difference of two unit circle angles, but I'm going to use a half angle identity here. Half angle sine is the same thing as cosine, except it's minus there, so it's plus or minus the square root of 1 minus the cosine of theta all over 2. 195 is a little bigger than 180, so that's which makes this a third quadrant angle, making this negative. So this is, we're going to have using negative 1 minus cosine of theta all over 2. The thing about 390 is equivalent. If I subtract off, I don't have two equal signs there. If I subtract off 360 from this, it's the same as 30 degrees over 2. So really I'm just going to use 30 as opposed to 390, because the cosine of 390 is going to be the same as the cosine of 30, because 30 and 90 are coterminal angles. So I'm not really dealing with 390, I'll deal with 30 instead. So the half angle of 30 over 2, again, what quadrant is this in? This is in the third quadrant, so half angle is going to be negative. I just wrote it as 30 because 1 minus the cosine of 30 is a lot easier to manage than with 390. So this is negative 1 minus cosine of 30 is radical 3 over 2 all over 2. I'm going to multiply by a common denominator of 2 over 2. So I get, oops, didn't change the color. I get the square root of 2 minus radical 3 all over 4. The denominator can be simplified to 2. And this was originally negative, so let's keep that negative sign. Okay, so here we have secant, half angle secant. Well, I'm going to use half angle because the directions say use half angle. Secant theta over 2 is the same thing as half angle cosine, except you take the reciprocal, so it would be 2 over the cosine of theta. The way I managed the previous problems is I multiplied the angle by 2 and then wrote it as a half angle expression. So if I multiply this by 2, I get 15 pi over 4, so that's 16. I said 16, that's secant. I multiplied this by 2, so this cancel, I get 4, is pi over 4 over 2. Let's check that. Well, 15 over 4 divided by 2 is the same as 15 over 4 divided by 2, which is the same as 15 over 8, which is what we originally had here. So we're going to use this for our half angle. The question is, what quadrant is 15 pi over 8 in? Well, I know that 16 over 8 is equal to 2 pi if I put a little pi in there. So that means this is just shy of the x-axis in one rotation. So this is a fourth quadrant angle. Since secant has the same sign as cosine, we're going to keep the positive. So this is going to be plus the square root of 2 over 1 plus the cosine of 15 pi over 4. Again, 15 pi over 4 is not one of those angles that I know. I forgot a pi here. So a coterminal angle of 15 pi over 4, so 15 pi over 4, if I subtract off 8 over 4 pi, I get 7/4 pi, and that's in the fourth quadrant, so now I'm good. So I get 2 over 1 plus the cosine of 7 pi over 4, which is equal to 2 over 1 plus 7 pi over 4 is in the fourth quadrant. Cosine is radical 2 over 2. I'm going to multiply by a common denominator of 2 over 2. So I get 4 in the numerator. That's really sad looking. 2 plus the square root of 2. That can be simplified. So I get 2 over the square root of 2 plus the square root of 2. Sorry, that was pretty sloppy work there. So our last problem here is 9 pi over 8. I'm going to multiply that by 2, so that gives me 9 pi over 4. So we're going to do the half angle tan of 9 pi over 4 all over 2. First question is, where is 9 pi over 8? Well, 9 pi over 8, it's a little bit past 8 over 8, which is the same thing as pi. So 9 pi over 8 is in the second quadrant. However, we don't need to worry about that because half angle tan is just the sine of theta all over 1 plus cosine theta. There's no plus or minus in this version of half angle tan. Clearly, there's the other one that is the plus or minus the square root of 1 minus cosine theta all over 1 plus cosine theta, but nobody uses that, so we don't need to worry about what quadrant 9 pi over 8 is. We just need to handle the sine and cosine of 9 pi over 4. Keep in mind, 9 pi over 4 is not one of those angles that I know. So if I take 9 pi over 4 and subtract off 2 pi, which would be 8 over 4, I get pi over 4. So really I'm taking the tan of pi over 4 over 2, which is the sine of pi over 4, all over 1 plus the cosine of pi over 4, which gives me the square root of 2 over 2, all over 1 plus the square root of 2 over 2. I multiply by a common denominator of 2 over 2. And that gives me the square root of 2 all over 2 plus the square root of 2. And that's a wrap.